Can I start? Good afternoon. I'm Han-Jong from Industrial Design Department of KAIST. I will present miniStudio, a designer's tool for prototyping Ubicomp Space with interactive miniatures. My co-authors are Ju-Whan Kim and my advisor Tek-Jin. Due to the development of information technology, the subject matters of design are changing from non-digital artifacts to digital and Ubicomp devices. Recently, the Ubicomp devices are embedded in a physical space and communicating with each other. The spaces consisting of various Ubicomp devices have become new subject matters for designers. However, it is challenging to envision user experience in the Ubicomp spaces. The spaces involve complex interactions, diverse forms and sizes, and have resources to be prototyped in the early stage of design. Currently, designers utilize scenario-based design method to deliver futuristic concepts, but it is hard to consider detailed interactions through acting on imaginary scenarios. On the other side, some development toolkits for Ubicomp systems were proposed in the HCI. However, these are difficult for designers to use without programming knowledge. So, we aim to develop a toolkit for designers without technical implementation skills to build Ubicomp Space prototypes. To deal with interaction prototyping for Ubicomp Space, our research was inspired from proxemic interactions by Greenberg et al. They suggested a framework to concern spatial interactions among people, devices, and non-digital artifacts. We applied 4 measurements of this framework to deal with invisible and complex spatial interaction for designers' prototyping. As related works of our research, several prototyping tools were proposed with designer-friendly environments, and augmented prototyping enhanced early design exploration with AR techniques. But these tools mainly focused on a single interactive product and limited to support large and complex Ubicomp system. Miniature-based system could support large-scale simulations such as urban planning or interior design. But the proposed system had a low flexibility to cover free exploration for new design concepts. And some development toolkits enabled to build real Ubicomp system, but it was difficult to use designers without high level of implementation skills. To support early design stage, we developed a prototyping toolkit for designers to explore Ubicomp Space idea with interactive miniatures and Photoshop. Our prototyping system was integrated with Photoshop as one of the well-known graphic editors. It generates miniature figures, and miniatures can be easily made with a mix of printed paper and Lego bricks. And we applied augmented prototyping to project digital images on physical miniature. The images associated with the spatial condition of miniature can also be made in Photoshop. After that, the camera-projector system projects the image on the miniature, and the image can be dynamically changed by tangible manipulation. miniStudio applies a mix of augmented prototyping, miniature-based prototyping, and integration of graphic software. It enables rapid and low-cost prototyping in a designer-friendly environment for dynamic representation on tangible miniatures. miniStudio consists of 3 functional components. The Photoshop plugin has Tool Panel and View Panel. And Tool Panel generates miniature figures and defines events. And View Panel enables users to identify the models and events in current workspace. The camera-projector system tracks hidden AR markers marker stickers attached on the miniature model. It projects digital images on the miniatures that are generated in Photoshop. Several tangible icons are used for triggering and controlling events. These are 5 types of events that miniStudio supports. Location of the miniature model, and distance between 2 miniature models, motion in a direction of left, right, up or down, and orientation of multi-sided miniature model, and custom events for non-spatial conditions. We simplified and reconstituted 4 proxemic measurements for our piranha paper miniatures. miniStudio supported 4 spatial relation events based on proxemic interaction, and custom event was added for non-spatial conditions. We applied one-to-one mapping of an event and an image. The event can be defined as naming layer group in Photoshop. When the group is generated by miniStudio panel, a layer inside the group becomes a state of the miniature model for associated event. The frame animation can be played with certain frame duration with multiple image layers. The Photoshop can be used for drawing a miniature surface in various ways, such as sketch-like or realistic images. This video shows an example walkthrough to define different states of the miniature model. The first step is building miniature model. A user can set type, size, name of the model to generate model figure. Then the generated figure has own identity number for attaching the marker sticker. Then the user can complete the miniature model after printing and assembling. The second step is defining event and images. When the user selects the event type and parameters, the event layer group is generated. The user can add a layer inside the group and generate images for defined events. The next step is testing and modifying miniatures. The user can test defined events and images with camera-projector system, and the user can easily edit images on Photoshop. And multiple layers inside the event group can be played as frame animation for dynamic representation. The Photoshop plugin was developed with Photoshop script for automated operations, and tracking software for camera-projector system was developed with processing and NI-Air toolkit library. The software reads the information of events and images exported from Photoshop plugin, and then it organizes images according to the spatial condition of miniature space. The hidden AR markers were generated by silk screen printing with white ink on a white reflective stickers. This technique was cheaper than using special material such as infrared absorbing ink. We used IR detection with hidden AR marker for non-obtrusive integration of miniature and projected images. We conducted user study to investigate the value of miniStudio and to identify the usability and areas for improvement. We recruited 6 individual participants and 3 pairs of graduate-level designers and researchers. We gave them a design assignment to design interactive bus shelter. The session consisted of 30-minute tutorial and 1-hour design session for prototyping. a debriefing session with post-interview was allowed. Total 9 interactive bus shelter prototypes were built, and they could be categorized as bus information system, communication space, and personalized shopping space. These are 3 examples of generated bus shelter ideas. The one is bus reservation system with color indicator instead of bus numbers. And another example is a public display that shows a map of visited countries for communication between tourists and local citizens. And a live public shopping system in the bus shelter was also demonstrated. Participants used distance event most frequently, and location event was used as pre-state of the distance event. Motion event was assigned to the bus to interact with remote components in the bus shelter. They used custom event to represent detailed interaction step or different time, such as day or night. Orientation event was used to represent different state of the miniature model instead of actual orientation. The participants regarded miniStudio was easy to run and use due to the Photoshop. After only 30-minute tutorial, they generated their interactive prototypes in about only 1 hour. We observed the usage patterns, and participants actively refined their prototypes after testing. Most of all, Photoshop could support both rapid generation and alteration of images. We found that they used augmented surfaces of miniatures for aesthetic purpose. They checked to compare the look and feel of the space, and some participants said that realistic human figure gave a sense of the scale, and it helped to decide the scale and the size of the entire miniature space. Moreover, the augmented surfaces were dynamic and realistic, so they felt their prototype is more like high fidelity. They were immersed in detailed representation of miniature space to explore design alternatives. The last finding was that miniStudio helped concretizing interactions of multiple components. They could check holistic interactions in macroscopic view of miniature space and freely moved physical miniatures for testing defined events associated to multiple miniatures. Due to the interactivity, playing with interactive miniatures could also enhance to develop interaction details. Participants thought aloud or did role-playing with their interactive miniature prototypes for concretizing their interaction scenarios. We found that there are further issues to be concerned. The first one is imperfect sense of the scale of the miniature space. To reduce gap between real scale and miniature prototype, magnified miniature view for immersive experience or using larger markers and real scale projection can be applied. On the other side, miniStudio is regarded as close to 2.5D. Using multiple camera-projector system can complement its imperfect expression of 3D space. The impact of miniStudio may be maximized when it is combined with or complements other design techniques. As participants did, role-playing or video recording is used to effectively concretize and deliver ideas in the early stage of design. And now miniStudio is integrated with Photoshop, but other designer software can be considered for effective event authoring and contents making. In conclusion, we present a designer's tool for prototyping proxemic interactions in large-scale Ubicomp space. A user study revealed that the tool supported iterative prototyping in the early stage of design. And we expect this research is to inspire designers' prototyping and future smart environment design. And this is the end of the presentation, and any question and feedbacks would be appreciated. Thank you.
Thank you. Thank you very much for a lovely talk. So, last opportunity before lunch to ask some questions, come to the microphone, say your name, where you're from, and then send us out with a positive, constructive observation. Aaron.
Oops. Hi, I'm Aaron Quigley from the University of St Andrews. Thank you for a very nice talk. I was wondering, do you think everything needs to be projected, or do you think you could blend between some things that are static, some things that are semi-dynamic, and some things that are highly dynamic? And is there any scope, do you think, for actually incorporating other digital elements? So if I was looking at this and thinking of putting in like small screens that could actually act in a more rich way. So the projection, how important do you think it is to have everything coming dynamically from a single projection?
That's a very good question. Actually, all the miniatures do not have to be projected, but our prototyping system is focused on iterative prototyping. So during the prototyping process, the printed figure or printed image can have a possibility to be changed. So we concerned that at that point, and also participants, actually designers, participants, they like the project image can be easily changed, or for focusing on the look and feel of the space. So,
but some of those shapes are constrained. Like some of those body shapes suggest one particular type of gender versus another. So there are constraints already in there. So it's not total freedom. Like I can't suddenly project in, Chewbacca that easily because I want my Chewbacca interface. So I'm just questioning, like, where is the line, do you think, between, like, what's the most important thing in this type of system to be dynamically created, projection-wise, versus what could be static? What's your expectation, or what's your impression?
So the
most important thing that should be kept as a projected dynamic?
Most important thing is iterative prototyping. So actually, we also consider that in the tutorial session, we let participants did some tests. So the making miniature figure is taken about lower than 5 minutes. So we think the regenerating the physical miniature is reasonable in time, and actually our system is integrated with Photoshop, so we focus on more on the digital images to be edited for changing for effective prototyping.
Okay. Thank you very much.
Okay, let's thank Han-Jong and all our speakers.